First paper from New Zealand, Dr. Kevin Lawrence will talk about infection of Friesian bulls with Theileria orientalis. Thank you, Doctor.
Thank you, Domo arigato. I've been waiting since the age of 12 when I read Shogun to be able to say those words, so I'm very excited to be here. So I'd like to present some work we did at Massey University, New Zealand last year, in which we deliberately infected a number of Friesian bulls and kept others as controls. And I'd like to acknowledge the work of my co-authors. It was a massive experiment for us to undertake, and I think it worked pretty good. So it's all about Theileria orientalis Ikeda. So as Masaru spoke about Babesia, well, Theileria is like its little country cousin. It's still an apicomplexan. That means it's an intracellular obligate protozoa parasite. We named our disease Theileria-associated bovine anemia. Other parts of the world it's called oriental theileriosis. It's transmitted by our only stock tick, which is Haematocrit longicornis, and they just love each other. It's almost like Puccini's Madame Butterfly. They really do get on very well. And when it hits a herd, we get about 1% morbidity and a 0.25% mortality. So you might think that's not a big problem, and in the big picture it probably isn't. But when you get an acutely infected herd, you actually get about 25% of the cows are anemic. Around the world, we've got East Coast fever, tropical annulata. We've got classically, Ikeda came from Japan, China, Korea, and then we've got the benign Theilerias, Buffelli, Kitose. And it was pretty exciting to actually fly into an airport named after a parasite. And then in 2006, Australia got it. 2012, New Zealand got it. We were under no illusions where we got it, because we imported some live cattle from Australia. It appears that Australia got it by importing some live cattle to America and then back to Australia, because there was no arrangement to import cattle directly into Australia. So movement of parasitemic cattle around the world, you run across a tick that can spread the disease and you get it. And I'm afraid, Masaru, you've already got it, you just haven't found it. When it hit us, 2012, it started off with just a few cases, mostly in the Northland, and then it spread quickly through most of the North Island. It's not very widely distributed in the South Island because the climate's not suitable for our tick. And this is where Massey University is, and we've just recently getting a lot of clinical cases in our herds. Above about this line, it's gone endemically stable, and we're just seeing cases in young calves, or anybody who's foolish enough to move a naive herd into this area will get outbreaks. So our experiment, we deliberately infected a group of Friesian bull calves, and we followed them for 20 weeks. We've measured the weight, the haematocrit, the rectal temperature, the activity, the fertility, and the libido. So there had been several payouts for poor fertility in bulls attributed to Theileria. So that was probably one of the background for the experiment, that we wanted to find out if it truly did affect the fertility of cattle. We started off with 22 bulls, and we intended to have 10 controls and 10 infected, but we lost a few more than we thought we would. We had one that was marginally positive, so we dropped that one. We had two that just didn't like girls. We had one that had a small scrotal size, and we had one that, when we got it into the service yard, it just wanted to beat the hell out of me, so we got rid of that one as well. We infected 10 of the bulls with blood from 2 infected dairy cows. The infectious dose was roughly about 6 times 10 to the 9 of Theileria organisms. And we kept 7 as uninfected controls. We used flumethrin poron every 4 weeks to control any ticks spreading the disease from the infected to the controls. We ran them as one mob. We fed extra feed through a ring feeder, and every 2 weeks I semen sampled them using an estrus heifer in a service crate. 3 times a week we recorded blood. We took blood, recorded the weight, took the rectal temperatures. We did that for 13 weeks, then dropped to once a week for the last 7. We put pedometers on them that didn't work very well. I don't know, maybe they're not designed for bulls after all, but we got some data from that. And then we assessed their fertility and libido. We did that every 2 weeks. We started 4 weeks before we infected them, so we got them trained up to using the AV, and that was when we dropped the 2 bulls that didn't like my heifer. So that's how we ended up with 17. On the bloods, we did PCV and PCR, quantitative. We took the numbers of steps per day. On the semen, we did volume, color, wave motion, forward motion, morphology, and density. This is basic data that we often collect as practitioners using a system developed by Tim Parkinson. And then for libido, we recorded the time to first mount, time to second mount, total mounts and the proportion that had a second mount, and the service order. And the service order, the bulls, actually self-selected when they came into the service pen. They would queue up, and the most dominant bull would push through to the front, and we'd let that one in. And we allocated them a score of 1 to 17 where they came in the order. The libido measurement, we gave them 5 minutes to make the first mount, and then they were censored and out the pen. And then they had 3 minutes after the first mount to make as many mounts as possible. And we started the timing as soon as the bull crossed the threshold into the pen. And as I've just said, we recorded the order the bulls came into the pen because that reflected any dominance. And this is a nice spring day in the Manawatu, and I'm hid by the bull. But that's our service crate, and we had well-grown Hereford Cross heifers as our service heifers, and they'd been injected with prostaglandin 72 hours before to bring them into season. If the heifer was unhappy, then we swapped the heifer, and we usually had 2 or 3 spares for each service. We successfully infected all 10 of the bulls, and we were also successful in not infecting any of the controls. We had a big live weight effect in 4 of the infected bulls, so 6 of the infected bulls grew identically to the uninfected bulls, but 4 of them actually showed a significant weight loss. They gained about 40 kilos less over the 20 weeks, which roughly on this spring's prices is about $112 a bull that they dropped. Now this graph. So the red is the uninfected control bulls. The black is the infected bulls that grew well, and these are the infected bulls that grew poorly. You can see that these bulls, all the bulls lost weight initially. We were just coming out of the winter when we started this experiment. We actually deliberately fed them a little bit below maintenance to simulate them working hard in a dairy herd. And so they all lost weight, but the ones that grew poorly continued to lose weight for much longer. If we looked at the infections intensity, so this is on a logs to 10 scale. So at the peak, we're up around 1 million organisms per microliter. But you can see that, and our cut point was based on optimizing the sensitivity and specificity, which was around about 415 organisms per microliter. And you can see that it climbed very steeply. But the bulls that grew poorly, they had a higher and earlier peak, whereas the bulls that grew normally had a later peak. And you can see that the controls always kept below the cut point. If we look at the PCV, this gave us, so the clinical effect of theileriosis is caused mostly by anemia. And you can see that both the infected bulls that grew well and the infected bulls that grew poorly, they both had the lowest PCVs around about 50, 60, 70 days post-infection. But the bulls that grew poorly also had this extraordinary hemoconcentration for the first 3 weeks, and nobody's ever seen this before. I hope it's not an artifact, because it's quite cool that they had a slightly different immune response to the infection. So they concentrate, but you can see that in the anemic stage, so anemia is classed as below 0.24, so the groups roughly just became marginally anemic at the lowest point, whereas the control bulls, it just fell gradually over the season. We looked at the temperature. There was no difference between the two groups of infected bulls, so we just plotted them as one line. And we had no pyrexia, so one of our hypotheses was that we'd get a pyrexia, and that would affect the fertility of the bulls. We had no pyrexia, and in fact we had a slightly lower temperature for the first 50, 60 days for the infected bulls. Activity, we had a bit of trouble with the pedometers. We were supposed to be able to download them whilst they're still on the animal, but we couldn't get it to work, so we had to take them off, take them back to the lab. It turned out that the infected bulls walked less on 101 out of 111 days, which was significant, but the amount they walked less on each day was not significant. So they didn't walk a lot less. And this is probably confounded by the fact that we brought the feed, the supplementary feed, to these animals. So if they didn't feel like walking, we were plonking the feed down in a ring feeder just in front of them. But they did walk less, the infected bulls. If we look at the wave motion, so roughly over 7 is a good score. You can see that the control and the infected bulls, they've pretty similar pattern, both for the wave motion and the forward motion scores. There's no significant difference between these two scores, and they would both be classed as normal for us. If we look at the semen density and morphology, there was a slight trend at the beginning for the uninfected, the control bulls, to have less abnormal sperm, but a score above 70% is considered normal. So there was no real difference here. There was this slight strange effect that the infected bulls tended to have more dense semen in the later part of the experiment, but for most of the time there's no difference. So number of mounts, so this is familiar to anybody who's been married, that the bulls started to lose interest. It wasn't them, it was probably me, but we can see the number of mounts fell over the period of the experiment, and the proportion making a second mount also fell over the experiment. There is no difference between these two lines. The infected line always being lower than the uninfected line was caused by the fact that one of our infected bulls only ever mounted the heifer once, the whole of the trial. It would mount the heifer and it would go in queue to leave the service yard no matter what we did. Time to first mount, very similar at the beginning, and then the control bulls just seemed to lose interest. They took longer to get the first mount, whereas the infected bulls, they continued to be less than 10 seconds to the first mount. So the infection somehow sharpened their appetite, I'm not sure, but the control bulls definitely lost a lot more lost interest over the experiment. We looked at the proportion time to second mount. It looks a bit all over the place, but it's quite interesting that around about 30, 40, 50 days, the infected bulls were taking a lot longer to take a second mount, and this is significantly different at these two time periods, that they were taking much longer for the second mount. This funny result here is caused by the fact that by this point only 3 of the control bulls were still bothering to make a second mount, and the 3 that were doing it were very quick. So it's a little bit of an artifact, that. If we look at this service order, I think this was probably one of our strongest pieces of evidence we got from this experiment. So we're back to the 3 colours. We're back to the bulls that grew poorly, the infected bulls that grew poorly, the infected bulls that grew well, and the controls. And you can see as the infection intensity peaked, we're getting this high count for these bulls that these bulls that grew poorly. So if you're going farther back in the service order, so if you're up the front, you're going to average with a low score. But if you're getting towards the back in the 15, 16 or 17s, you'll end up with this high average score. And these two scores are significantly different. So at this point, these bulls that grew slowly were getting farther and far back in the pecking order, and the controls were getting up the front. And then at this point, these are also significantly different. So we got this effect on pecking order, that these bulls that were infected, they were getting pushed more to the back, but it was only temporary, and once again they were back fighting for their place. Now this isn't caused by anemia, because the anemia actually didn't come on for maybe another, today, 50, 60, 70. This is caused by the infection, I'm sure of it. And one of the things that theileriosis causes is this lethargy, anorexia, and I think this is a part of it. So our conclusions was there can be a significant weight loss, even in adult animals, even in 2-year-old well-grown bulls, and possibly 40% of them may lose weight. There could be an effect on libido, which may only be temporary, but there doesn't seem to be an effect on semen quality. And that level of the libido effect could actually be related to infection intensity and not to anemia. Okay, and I wouldn't recommend doing this at home.